Pouring liquid nitrogen onto nitrogen triiodide. Instead of jumping right into the experiment, I'll first give an intro on nitrogen triiodide. Iodine is one of the existing elements of nitrogen triiodide, and also the heaviest element of the stable halogens. One of the main properties of this element is that when it's heated in normal pressure, instead of melting it sublimates, which forms to a violet gas. And now to make nitrogen triiodide, the contact explosive chemical. Its instability is so much that it literally explodes with a touch of a Kleenex. To make it, you'll need about 3 milliliters of 30% pure ammonium hydroxide, about 0.3 grams of iodine, a mortar, a weighing paper, 2 test tubes, an ultrasonic bath which is optional, a pipette, a filter paper, a funnel, and distilled water. First, smash the iodine in a mortar into small pieces. Place it on a weighing paper, slide it into a test tube, add the ammonium hydroxide in the test tube and mix it completely with iodine. For mixing, I prefer using an ultrasonic bath. Keep in mind that you don't need to expect forming a homogeneous solution. Actually, you can't. You just have to get rid of all of those smaller iodine particles. Now you need to cut a filter paper in a circle, bend it 2 times, form it into a quarter, shape it like a cone, insert it in a funnel, put the funnel in a separate test tube, pour the first test tube in the test tube with the funnel, spray off the leftover with distilled water, and pour it again on the filter paper. You can see that the ammonia solution is separated from the wet nitrogen triiodide. As long as it's wet, it's safe to touch. Put the brown precipitate somewhere safe away from any contact, even the wind. Oh, and also don't put it against sunlight exposure with the thought that you could dry it faster. It decomposes instead. Leave it for about 1 to 2 hours to completely dry off. Well, congratulations! You've made nitrogen triiodide. Before the explosion, I seriously recommend putting on a noise reduction earmuff and safety glasses. As you can see, it explodes with the slightest contact. During the reaction, I2 is released as a purple gas and N2 is released as an invisible gas. But why did this happen? Nitrogen triiodide contains 1 nitrogen atom and 3 iodine atoms. Since iodine's atomic radius is way larger than nitrogen's radius, it makes it so unstable that iodine's atom detaches instantly from the nitrogen's atom with the lightest pressure. But you know what? This isn't the real structure of nitrogen triiodide. According to these 2 articles, nitrogen triiodide could hitherto only be prepared in the form of a donor-acceptor complex with 1 or 3 molecules of coordinated ammonia, which ended up to look like this. And also, all of the nitrogen trihalides are unstable except nitrogen trifluoride. Now, let's get into the main subject. What happens if you pour liquid nitrogen onto nitrogen triiodide? I mean, since liquid nitrogen has an extraordinarily low boiling point of minus 196 degrees Celsius, theoretically, you could increase nitrogen triiodide stability by not providing the activation energy of nitrogen triiodide's explosion. This scientific manuscript confirms the mentioned theory with this exact sentence that in solid state Ni3 is stable at minus 196 degrees Celsius. So let's get started. To do this, I redid all the steps again with the difference that I piled up the nitrogen triiodide in a container to hold up the liquid nitrogen in it. Due to the explosion aftermath, the container shouldn't easily break. I started pouring the liquid nitrogen inside the container. You can see that some of the nitrogen triiodide particles ran off the container. They just acted like small piles of nitrogen triiodide when dried off. I poured some more liquid nitrogen on it. Now that I knew that the temperature of the container is about minus 196 degrees Celsius, with a lap scoop, gradually I increased the pressure applied on it, until a small pop. As I said, of course, the stability was increased. when the liquid nitrogen completely evaporated. I noticed that the nitrogen triiodide has preserved its explosive properties. But wait a sec, was an article with an impact factor of 12 wrong? Cause it said that nitrogen triiodide stable at minus 196 degrees Celsius. Let me know in the comments below. Oh, and also like and subscribe for more videos. Adios.